All right. Welcome back to another session for the AI class. So today we're going to continue on the most important library for me in Python. It's called Panda. So Panda is like probably the go-to tools for data scientists, but I guess for general office data manipulation, I think it also works very, very well, and also for me too. Okay. So in order to use it, if you get the Python installed correctly, you should be able to run import Panda as PD. So PD is convention, so you can come up with any other names, but nobody use any other names except PD, okay? And let me just show you this. I'm gonna have a data. Let me see, let me just open this one, okay? So this data is written in terms of the dictionary, right? So as you can see that there are, key, which is apple, and then there's a data like 3201, and then there's another item, which is key, orange, and another list, right? So in order to compare pandas, I want you to think about Excel too, right? If I were to have Excel, and I want kind of like the same thing, I would do something like this, right? I would want maybe apple and orange, something like this, right? Okay. Like that. And then my data would be something like 3021, 3201, right? And then that would be 0372. So a similar way of thinking about Excel is something like this. So here I'm going to put this data and then into the Panda library. It's called data frame. So just bear with me for a second. I'll explain what it is, right? So I'm going to do pd.dataframe. So this is a command that you create a new, I would say, class instance. So we talked about class last time, right? So this is a class instance of the data frame, which is, I'm going to put in the data, okay, just like that. And here I'm going to set it equal to, I guess I set it purchases, right? And then like that. Wait, I have to run it, okay. Okay, so once I run it, let's inspect to see what type of the data the purchase variable is, okay. So if you go to terminal and go to Jupyter, then you're gonna see that right now we have the variable named purchases. Its type is the data frame. So the new things that we're gonna encounter today is data frame. It's the class, right? Inside the class, there are methods and attributes, and this is the instance of that class. So it has all the useful method to deal with the data manipulations, basically, okay? And it even has the size, like 4 rows and 2 columns, right? If you go back to Excel, you have 4 rows. But I mean 4 rows mean the 4 rows of data, okay? Because in Excel, you actually have the extra header rows, right? So in Panda, when things are in data frame, it's like, for me, I think of it as like supercharging Excel, like the better version of Excel, for example, right? So you can simply just type purchases, and then it's gonna show your data for you. And as I was saying, right, this is pretty much like Excel, the tabular data, okay? Okay, so the thing about Panda is that when you have data, there has to be a way to locate the data, right? So if I were to talk about Excel, for example, how do you locate this data, for example? Like, for example, this one. Usually in Excel, you would locate it by the column index. This is A, right? And then you also have the column index of the row index of 2. Same thing with Pandas. If I were to do Pandas, you would see that you would have the column and you have the row. But the first thing that I think very useful in Panda as compared to Excel is that, as you can see in Excel, the column index is fixed because it's got to be alphabet, letter. Like, you cannot change ABC above. There's no way, right? So since you cannot change a column index, then you're left with the header row. So in every Excel, you got to have the header row. That's the extra row that we don't actually need. It's there because of the limitation that you cannot set the column index to be anything you want. But if you look at Panda, this is really nice because The column index is actually something that we can set. So we can say that we want the column that's called apple, and we can have the column that is called orange instead of column A and column B. Right? So that's the thing that I find very useful when you locate things. You locate it by column index, which is something that we can set to be more meaningful. Okay? And the other thing is the row. So right now, you can see that the row index are 0, 1, 2, 3, right? In Excel, you would have similar things because you would have a numeric number as the index, okay? But the cool thing is that actually the row index doesn't have to be number in Panda. It can be anything that we find it meaningful. So let's do just that, okay? So I'm going to do something like this. Instead of inputting just the number, input just the data itself, I want to say that the index, and this is the row indices, okay? So I'm going to say June. Okay, let me just copy it because it's kind of long, but what I refer to is this list right here. So this is the list of string. So I can say that my indices, this is the row indices, will be that one. If I were to run it again, and I did like that. So this is very useful because when you want to locate things, you don't locate it by just alphabets and number. You locate it by the index that makes sense to you. For example, I want Apple and June, and that gives me number 3. That's how you locate things in Panda data frame. And this is very useful once you start to have lots of data. And then where is it? If you have indices that make sense, your code actually make a lot of sense. Instead of like locate things by 0 to 3, you're doing something like that name. Okay, so let me just show you how to, what, did I go too fast? Oh, actually no, that's something that I want to do next, okay? So let's say I want to locate things in Pandas. I can do something like this, purchases, right? And then dot, okay, dot mean accessing the methods or the attributes. And in this case, it's kind of attributes, right? Look, what's the location of it, right? And it's similar thing to how you select things from like the list or a string. You're going to put the square brackets, right? And let me just do something real quick, like for example, row indices like June, like that. See what happened, okay? So what happened is that if I do location of June, June is the row indices, right? So it's going to give me the things that in that row. So I get 3 and 0. Okay, so as you can see the results, I get 3 and 0, okay? But then it's, for the newcomer, it might look a bit weird because the way that it display the data, it display everything by row if it only have one dimension, okay? I guess I'll just tell you right now, it's called series, but I'll tell you more, I'll look into more detail later. But this is called the series, it's another data type, right? But again, I get 3 and 0, right? But here's the cool thing. Even though I only ask for one row, it always gives me what's the other dimensions indices, just to make sure that I don't miss it. See, I get 3 and 0, but then I know that 3 come from the column apple, and that 0 come from the column orange. So in Pandas, you always get the indices of the other dimensions correlating to what you are choosing, which I find it pretty nice because now I can kind of trade things back to see where it comes from, okay? If I want to select more than one row, of course I can, right? In the string selections or list selection, you use a colon, okay? So you can do just that. I'm going to select from June to Lily. Do I have it here? Yeah, I do have it here. So I'm going to do colon, Lily, and see that, okay? Like, the thing that I like a lot is that when I read this code, I actually know what happened instead of just numeric numbers. Like I know where I want, right? If it does make sense in terms of, I think it's more self-explanatory that way, okay? And as you can see that if you are returning things that more than one dimension, it's returning what's it called the data frame, another data frame too, okay, which is smaller, okay? Okay, so why don't we do more ways of selecting things. I think we can do something like this too. If I were to do, that doesn't work. Maybe I can do, oh, actually, let me try. I haven't used this method for a while, but yeah, that doesn't work. I have to do that, right? So that is a column. Yeah. Yeah, I can do like something like this too. If I do June and Lily inside the brackets, so that means I want to select the 2 rows, but then they're not contiguous. Okay, so I can do maybe like 3 rows in it. So like David, you can try something like this. So the row that's not contiguous too, possible. Or you can even do something like June and from Robert to David. Like there are many ways to slice your data frame. Like, oh, that doesn't work actually. So sorry, have to do something like that. Okay. 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 This is the selection from rows, right? But then there are many ways. But if you want to do the other direction, let me just go there right away. I didn't have it here, but probably later on in my example. But when you want to do row selection, it's lock, right? But for the actual columns, you can actually do something like this too. Purchases, and then I simply can just input the columns into it. For example, I can do Apple, like that. Okay. Oh, did I do it wrong? Apple with S. Okay. So something like that would work too. Okay. So and as you can see that this one gives me 1 column. I can also do like just the orange columns only. Okay. Something like that. Okay. So that would be select the entire columns. Okay. So but then if I want to do both the selection between columns and row, now you gotta have to do like a 2-dimensional thing like a matrix, okay? So I can do purchases dot lock, but then now I can have the first part is a row and the second part is a column. So I can do something like I want to do Lily, right? And then I want to do orange. Let me just try this one first. Actually, this one doesn't work. I have to do this and then do orange. Okay. Something like that. Okay. Let me just make sure I get it in the same format. So the format is like this. So you're going to do, okay, like that. The first part is the row that you want to select, and then the second part is the column. So if I want to select more rows, I would do something like Lily, and then I want to do Robert, right? Okay. So see, I have 2 things, okay? And if I want to do more columns, I have orange and apples, something like that. Okay. The way that it works is kind of similar to like when you do the matrix, the rows, it's the first part. If you want to do multiple things in the first part, you put it into the list. Also, a similar thing, the second part after the big comma is something that you would want in terms of the columns. If you want multiple columns, you also put them in the list too. Mm-hmm. I think colon would work. Yeah, colon would work, but why doesn't it work here? Oh, okay, if it's, I think you have to do it something like this. Yeah, something like that would work, okay. But let me not do that right now. It's kind of confusing. There are many ways you can do slicings in Panda, and it's kind of overwhelming for the newcomers. But for me, my recommendation would be to stick with this notation, which is if you want to do any rows and column slice, you do it with the list. Okay, that would be the first thing I recommend. Okay, but then there are many shorthand ways to do it. So that's why it's kind of confusing if you look into the documents. Okay. Yeah, because there are other ways to do. For example, you can do Lily and then colon without the list. Something like this would be possible, like something like that. Yeah, but I guess that's too many, too little. I do David something, right? And then this one should be apple to orange. Something like that. That would work too. Okay. This one I should switch. Okay. Okay, something like that. Okay, so there are the longer way to do, and there is a shorter way to do. So notice the little difference between putting things into the list itself, or if you don't have the list, you can have the colon to have like a continuous range. Okay, so that's something that you'll get used to it after a little bit of tinkling around. So it requires some getting used to in the first place. But trust me, once you get used to it, and you will have like one pattern that you like a lot, and then you're gonna stick to that, and that's what ended up happening to me. Like I just choose one notation, and then I just keep repeating that. Okay, moving along, I want to show you that conversion between, when you have the data frame, you can convert into other type of spreadsheet document for file format very easily. For example, one of the things that people like a lot is the exporting to Excel, for example, right? So you can do that. So purchases, right, and to purchases to Excel. I guess I start with the CSV first, so we'll just do just that, to CSV, okay? And then you're gonna have the file name. I name it purchases.csv, okay? And that's it. If you just, and again, to CSV, it's the class method. So this is the function, and it just requiring the file name. And once you did that, you're gonna see that there are files happening in here. You can even open this file in the normal explorers, and it should open in Excel, like that one, okay? So as you can see that it has to convert the row and index into the separate columns, because or else the conversion will be, the data is lost, okay? So that is CSV. So CSV is usually used for, I guess, transferring to other programs. So some program doesn't like Excel, so CSV might be the way to go. But I guess for most people, Excel would be the, I guess, the go-to choice. So I'm going to do purchase sets to Excel. So that would be something I use a lot when I, after I'm done processing the data, I export to Excel, send it to other people. So I'm going to do purchases.xlsx, okay, and just hit enter. And now I got another Excel. So if I open this in my just regular Explorer, that's Excel. Here we go. Okay, see if it works for you.
Can you show the code again?
The code? Okay, right here. I use this all the time. Like, I do stuff in the Pandas, and then I export to Excel for other people. Oh. ง่ายครับ Okay, your classmate was asking about data import, which I'm gonna show you just right after this. Okay, so maybe we'll just do it like that. Say if I have Excel or even CSV data, it can be easily imported to Panda. I do that all the time too. So it's called pd.read Excel. I think that is also in your example too, but I'm gonna show you anyway. Okay. So PD is the module, and read Excel is the function to read the Excel file. So just give them the name. Usually if it's on the same folder as this notebook, then you can just type the file name like purchases, right? .xlsx, and that's all you have to do. And then you can put it into another variable. So I'm going to say purchase, well, import. Maybe purchase import equal, something like that, just to make sure it's a new variable. And I hit enter, and I can just look at it like that. There you go. So once you export into Excel, you can try reading it in to see what happened, like that. Okay, but if for those who are paying attention at the data that got imported, you might see that there is something a little different, right? Because the data that we export looks kind of clean, right? It has just a row and then the column indices. But then when we import the data again, it looks strange because it has this extra columns, like here it has the indices that is now numerics, right? Before it doesn't have that. And now it has this, like this column should be the index, but it now has the name of unnamed 0. So that happens. So let's understand what's happening, right? So let's see the data that, the original data first, not this one, but this guy right here. So this is the data that we're reading in. And if you're Panda, right, you would not know that this should be your indices. Like if I were Panda, I would treat this as another data. And if it doesn't have any name for the columns, then the default name is unnamed. So that makes sense? So I guess the Panda library make no assumption of what your index column would be. So we have to tell it what would be the column that gives the indices for the row, okay? So, and for that, we can add in another option. So we have to do index column equals 0. So that means that this one's going to tell the Panda that, okay, I know that there are 3 columns, but the first column, you should use that as the row indices. And if I do that, then the data look normal again. Okay, so just keep in mind that when you read things back, there might be, the columns that represent the row indices that might happen, that might appear as another columns of data. But it can be fixed very easily. And if you feel adventurous, you can try reading your own data and see what happens. You feel adventurous. If not, you can use my prepared data. Okay. Okay. So let's continue a little bit. So right here, I have the data. It's called the movie data. So before we load it in, let's look at what it is in Excel. So I'm going to double click. So keep in mind that this is a CSV data, but it works the same way as reading in the Excel. So, so these are the movie detail from the database online. And these are the, I guess you can see like rank, title, genre, description. And there are, I guess, like maybe like 10 or 13 columns. And there are, I guess, 1,000 rows. Okay, so pretty small data. But as you can see that if you have something like 1,000 rows, like scrolling up and down, start to get a bit cumbersome. And imagine if you have like 30,000 rows, like opening in Excel would actually start to slow you down. Okay, so that's where Pandas is very useful. Like if you find it hard or like hard to open or slow to open in Excel, then you use Panda. Okay, so let's read that data in from the Panda. So make sure that you close the file first. It doesn't allow opening the file that's opened by other programs. So close it, and then I'm gonna read it in. So the way that you read it in from the CSV file would be pd.read CSV. So similar to read Excel, you would read underscore Excel. So this one read underscore CSV, right? And then the file name. And the reason I can do this is because my file is actually in the same location. If not, then you gotta do some command line thing like dot, like go up one step and things like that. So we'll talk about that later if you need it, right? It's a way to locate file in another folder. Okay. So you do the name of the file, IM. So let me just copy it. I don't want to make mistakes in here. This guy right here. Okay. Oops, I need. Okay. Again, if I just do that, okay, I'm gonna put into the variable called movies underscore df. So df, if you see df anywhere, it's probably mean data frame. That's kind of like the shorthand that everyone kind of use it all the time. Okay, do that. And again, if I want to look at it, what it is, I can just type movie df and see what it is, right? So again, it's not trivial, right? There are probably like 13 columns and a lot of rows, so you cannot see everything, but it kind of gives you, the top and the bottom at least, just to get a glance into your data. But here's the thing: there's still something we need to do, because remember, we still have this kind of indices in here, right? Which doesn't mean anything. I think something that, like, when you decide what should be your indices, first, it should not have duplicates, like, because that would be bad if you want to locate duplication things, right? And the second thing is that what would make sense if you want to access it? Like, what would be the most, I guess, self-explanatory way to access your data? Like for me, I think title would be something that makes sense when I see the code and I want to select a movie. I select by the title. Like you can set the title to be your indices, for example. So let's do just that. Okay, so I'm going to do index call. Remember, this is the way to tell the library that I want this column to represent the indices. Okay, so it's going to, you can do by numerics number, or you can just type the actual header, like title. That also works too. Okay, you don't have to count it. Just type the title. Like title mean titles in here, which I think needs to be capitalized too. It's capitalized, the big T.
If you just put one instead of title, it works too.
Sure, it should work. Let me try that. Everything. I'm not sure. I mean, I'm pretty sure it will work, but let me try that. Okay, so that works, right? Well, it works because now you can see that this one is not the regular title. Like this one is the name of the indices. As you can see that it's not on the same level as the regular title name, the regular header name. But let me try that because why not, right? One, right? Yeah, works the same way. Yeah, works the same way. Okay, but if possible, I want to keep things self-explanatory. So And that's the whole thing about Panda. Like it makes you write code in such a way that when you come back 3 months from now, you know what it is. Not just a number, it's like the actual tape name. So that's what I really like about it, okay?
More meaningful to
Yeah, exactly, yeah. When I go back to my file, it actually makes sense, yeah. Okay, so normally I do not recommend just type it in like this. I mean, certainly you can, but it probably, if you have like big data, there are better ways to get the glance of your data. For example, you can do movie, I guess your variable .head. Head is a function, so you gotta call it, meaning that you gotta put the parentheses on. So head just gives you the first 5 columns, 5 rows of your data. So that's head, okay? And of course, if you want to know more, you can put in the number, like maybe 10. If you do head 10, that gives you the first 10 rows of your data, okay? Like that, okay? So you can do head or head with the number, or like something, like for me, I would just do like maybe head 2, because I guess the file is too cluttered, okay? So I'll do head 2. And if you have the head, why not tail, right? As you might have guessed, the tail, so it gives you the bottom, the last couple rows that you want. So tail, and if you just do tail without any arguments, it's going to give you the last 5 rows of your data. But if you give it a number, for example, like maybe 2, then that gives me the last 2 rows of the data. So usually I do heads and tail just to see. I do head because I want to inspect what columns do I have basically, and just maybe like just couple data to see what happened. Okay. So that's something you might want, but then heads and tail might not work very well if you have a lot of columns. Then you're gonna get overwhelmed by just scrolling to the right. So another, I guess, more useful in that case would be info. So I'll do movie underscore df, but then I do .info. Again, this is a function. You got to do parentheses. Okay, I do that. So this one, I guess, it's not as graphical, but it's very useful. For example, this one gives me the columns. So this is the column's name, right? Without the title, because the title is now the index, right? So the thing that I like about this is that I can look at the data type. So that will become quite important once you start to do data manipulations, because you gotta know if it's string, if it's number, or if it's the mixed type, which is object. So object is, like you have mixed type, or you have a more complex data like list, then it might put things into the object. I think string is also an object in Pandas too. But another thing that I like is right here, 1000 non-null. So it's saying that I have 100 entry, 1000 entry. So that means I have 1000 rows of data. But then I have 1000 non-null entry. So that means that my column doesn't have any missing data, right? And if you keep looking down, you can see that revenue is actually missing some of the data. And this is quite important as a data scientist. If you have missing data, and in machine learning too, if you have missing data, you got to do something about it, right? And right off the bat, you can see how useful this function is, because let's think about this. If I have to maybe inspect the actual thing in Excel, and I mean, how would you know that there's I guess I know there's missing data, but like, how would you know how many missing data there is, right? You gotta kind of look around, right? Okay, well, right? So it can be done, but I mean, why not just do that? And then I can see, okay, I gotta do something about this, I gotta do something about this, right? Something like that. So I look at this all the time, first right off the bat, just to see if I need to do some data imputations or not. Filling in the data is called imputation. Yeah. Okay, so let's not do this right now, but do some more data manipulation, like changing the columns and things like that. Okay, so if I want to access the column name, I can certainly do that. So movie df dot columns. Okay, just like that. Okay, so it gives me a list. I guess it's not really technically not a list, but it's an, I guess it's an index list, right? Which if I want to do even further, I think I can do something like this, dot values. I didn't write it in here, but I'll just tell you right now. Like in a lot of cases in this library, if you just want the value out, you can do value. And then now you got an array, okay? So actually this one is the NumPy array. NumPy is the list from the library from last time. But if you want to do the actual Python list, you can do toList. Okay, that's the actual list. Okay, so there are many layers of data representation. So for example, this one, if you only do this, it's an array, but it's wrapped inside the index class instance from Panda library. If I were to do dot values, that gives me the NumPy version of it. And if I were to do toList with the parentheses, that gives me the kind of like vanilla Python list. Okay. This kind of data transformation, it's important once you go into, you know, like if you want to do data manipulation, and you want to do like maybe you want to use NumPy functionalities, then you might want to stop at the values. But if you want to do maybe, you know, like Python list manipulation, then you go toList. So that would be something that might come into play later on, but probably not now. Okay. So if you want to do changing the name of the column, right? We can do that too. And but this you're gonna find it quite I guess more work than just Excel, right? This one I agree. Okay. So it's gonna be rename. Okay. So if I do rename, then in here I gotta tell what do I want to rename. I want to rename columns, and then inside they're gonna be dictionary. And in here, if I want to rename a columns, then I need to give them the original column name, like rank, and then I can do I guess the new name. For example, let me just do rank 1 or something, and that's it. Okay. If I were to do this, you can see that I have renamed it. Okay. So for this, I agree that there are certain I guess certain process that in Excel it's easier. In Excel, you can just click at the row and just change it, right? In Python, in Panda, for example, like changing the name, you got to write some code which can be more cumbersome in certain cases. Okay. So in here, I show you that I changed the name of the columns. Let me see. Runtime. And then, okay, so I changed the name. I removed the things in the parentheses. So let me do just that, okay? Like that, right? Which, I mean, if I were to look at my results, I should see the runtime and revenue without the parentheses, which looks right, like runtime and revenue without the parentheses. But here's the thing. This is quite important when you work with Panda library. If I were to go down here, okay, and if I were to type movie, df again, and maybe I'll just do head just to make it shorter, like 2, you can see that now the parentheses come back. Like what happened, right? It doesn't change at all. Like above here, if you see before, this command, like rename, right? I want to rename this, get rid of all these things in the parentheses, and if I hit enter, it shows me the version without the parentheses, without the units, right? But if I come back down here and I inspect it again, you will see that actually it doesn't get changed. So this is something quite important with Panda design. This is the design. So I guess in data science, if you want to replace your data, you have to tell the library specifically that you want to replace the data, because replacing data is dangerous. Like you can get into a lot of trouble if you replace the data accidentally. So that's why by design, if you were to do something like this, it would just show you, okay, this is what happened if you were to rename the column, but your original data is still the same. Okay? If you want to replace your data, you have to tell them specifically. For example, I have to write more option. For example, in place equal to true. And that tells the library that, yes, I want to replace my data. Please do so. Okay, so I think this is a good design. Like in data science, replacing data accidentally can be disastrous. So this is good, okay? So if I were to do in place equal to true, like in the example, then you will see that if you were to create a new, like if you were to inspect it again, then my data is now changed permanently, which is good. I like this design a lot, okay? Because like usually I just do like, okay, what happened if I do this? And once I'm done, then I can replace it by just writing the command like this, okay? This is one way of telling the Panda that you want to replace. There's actually another way to do, which is also equally valid, which is something like this, okay? But here's the thing, I gotta change it back, because if I don't change it back, it's gonna give me error. So let me just create another temporary code just to change things back. Okay, so I'm gonna do this, right? Change it back into this one, okay? Or else I cannot run this code again. Okay, so right now I'm changing my columns back to the one with the units, right? I'm doing it right now. And just to make sure you wanna confirm, so I'm gonna inspect my data again. So let's see, it has the units, right? So if I want to do this, column change, but I don't want to do this, like this is something I don't like for my personal reason. But the way that I like even more, if I want to replace my data, is to actually do this, movie df equal. So I like the way, let me just show you first that it works. So if I were to do like this, I press enter, right? And then I inspect my data again. You can see that now I don't have the units anymore in my column names. The reason that I like this more is that this one is more explicit in terms of, I guess it's called the immutable way of writing the code. So when you say immutable, it means that you don't change things, you create new things and you replace it with a new thing. So that's I guess the coding pattern that I like more because I came from another language and immutability is kind of the big thing in the other language. So for me, I prefer this way, okay? But you can have in place equal to true, that also equally valid, okay? And in here, I show you another cool tricks if you want to change things, I guess, a lot. So you can, for example, if you want to change all of this into the lowercase. So right now, all of my columns are in uppercase, right? The first letter is uppercase. If I want to change all of this into the lowercase, I can do something like this, movie df dot columns. I'm just going to replace them with a new name. So this is essentially like going to Excel, each row, each cell, and then just keep changing the name. So you have to type them explicitly. So you can certainly do that. Nothing wrong with that. But since you are doing code, then actually I show you that there is actually a better way. So this is the code that change things into, change the case of your column names, but I guess more expandable or scalable in terms of the number of columns. So let me just run this one real quick, okay? So this one will give you the new columns with the lowercase, right? If I were to do movies, df dot, dot head 2, then you can see that my all of my columns are in lowercase. But if I want to change things in the uppercase, I can certainly type things again. There's no problem with that. But let me just show you that this code also do the same thing, but it will do it to any name, column names, no matter what. So this one is a better way to do, right? Just like that. And then I can do movie df.head2. And right now I have the uppercase columns, okay? So I guess as you develop, like in your journey in using more Python, a lot of things that manual like this will get replaced by something that is more, I guess, more algorithmic way to do it, okay? Okay. Yes, thank you for asking. Let's do that. Okay, your friend was asking about if we have more than one sheet, you can. Let me just do that. Okay, A, B, C. So I'm just creating another sheet called sheet 2 in the purchases.excel. I need to close it because if I don't close it, then it's going to give me error. Okay, and let me just do this. pd.read excel. I'm going to do my file name purchases.xlsx, right? And you can certainly have the option called sheet names equal sheet 2, like that. Yeah, certainly you can. You can even write things in multiple sheets too. But that's, I have to look up the code. It's not, I don't remember the top of my head, but you can write things in multiple sheets too. Yeah, I do that from time to time. And I guess if I were to continue with the changing name, there's actually another way that is super short, but I didn't tell you this trick before. This way, this code is just one line, it's just, I guess, couple character. What this code is doing is actually changing all the column back into the lowercase. But as you can see that this syntax is new. This one is called list comprehension. Let me just point it out to you. It's kind of like the advanced way of writing Python loop without actually writing the loop itself. So it's called list comprehension in Python. This guy right here. So it's a shorter syntax without writing the loop. So instead of writing maybe 3 lines, you just have 1 line like that. So I guess programmers are too lazy to write 3 lines. So we have 1 line way to do things. I don't use it that much, but I do use it from time to time if things are easy enough, for example, like this. But for the newcomer, you don't have to use this one because it's kind of confusing. So you can do for loop. It makes more sense to me in the beginning. But I just want you to be aware that as you get more advanced, your code is mostly just going to be like that, just 1 line. Like changing all the columns into lowercase in 1 line, no matter how many columns you have. That's the power of Python, okay? So let's do just that. And if I were to do movie df.head again, now my columns are in lower cases, right? Like that, okay? So that's the level that actually if you hear, then you can do a lot of things pretty concise with concise code, I guess. So right now we have the data frames with the lowercase column. I guess if you run down the example, okay. All right. So that's changing columns. Probably not that useful because you can also change. Like I guess to tell you the truth, like I find myself a lot of time just go back to my Excel and change a column in Excel if it's not a lot. So I don't use this technique that much. Another thing, but I do use this one quite a bit. So if I want to see, like if my column is numerics, I think stats, like basic stats is quite useful. So check this one out. Movie df.describe. This one is pretty cool. Check that one out. So this one, it picks the column that is numerics. So the one that are strings doesn't get picked. And it's going to give you like the basic stats like count, mean, standard deviation, mean, max, and the quartile. So for example, like if I, like whenever I get columns that are numerics, like why don't you just look at this? Like this one is pretty cool. Like you can do that in Excel, but a lot of clicks. This one, just one line, and you basically get the whole thing. And if you want to go further, you can even extract this data out and then do some more manipulation with it too. Maybe I'll show that to you if we have a chance. Okay. And also you can pick just the columns that you want. I show you that I want to pick just one column like movie, DF, right? And if you want to pick one column, there's many ways to do. You can, I guess my recommended way would be to use log. Like for now, I think I guess the longest way, but makes the most sense to me at the beginning would be to use log. And in the log, remember, you're going to have to put two things, the row and the columns, right? If you want to pick all the row, you do colon. Colon is every row. If you do colon here, that's every columns. If I were to do that, I get the whole thing, remember? But then I can also do, I can pick specific things using the list, right? So if I were to do here, I want to change columns, right? I want to pick specific columns. I put things in the list. So I do columns, and I can do rank, and I can do maybe just pick one more, like descriptions, like that. It has to be in string. And here, see, I got these two things right now. So see how powerful this is? Like the way that you select things, this is something I really like. Okay, so I recommend this syntax. But I guess in my example, it's a bit shorter, right? Because once you do this a lot, then you're going to use a shorter syntax, which kind of omit a lot of things. But for the beginning, try LOC, log first. And in the log, there's always going to be like row and columns. And try to pick things that are in the list, okay? So if I want to do 3 columns, I would do like runtime in here, right? Like that. Like that. See, I have runtime. Okay. So if I were to do something like this, then I can say dot describe, and now I only have a couple things to work with. So you can also chaining operation like this. So you select thing first, and then you just dot describe into it, so that you can have I guess a shorter, I guess more filter results in a way. Okay, as you can see that if I were to do describe, well, I only get the column with numerics, right? But the description is kind of lost, right? Let me just pick one, something that will give you some, make more sense. I want genre, so this one can be useful. So if I were to pick 3 columns, for example, and I show it to you, yeah, I do have 3 columns in here, right? But then if I do describe with the parentheses, I only get the stats for the column that are numerics, which makes sense, right? The genre is just a string, so you don't do statistic with it. But what else you can do in terms of you have like string columns? You might want to see the frequencies of the value itself, right? So and that is something very useful. So let me show you this. I want to do movie df dot log, right? I think I'm gonna use log first, even though it's not the shortest syntax. So I'm gonna do all the rows, and I want to do just one column, which is called genre. Okay. So let's just make sure that it is right. So genre right here. So as you can see that even though I only choose one column, you're always going to get the indices. The indices, the row indices is always exist no matter what. And that's the good thing because we want to know where it comes from, right? But I can also do value counts. I think that's something that I really like because if I do value count, you can see that now I know the frequencies of my entries. For example, I know that in my list there's a lot of I guess the most type of movies that I have in my list is action, and followed by drama, things like that. Okay. Let me see if I have more than one type of, I don't remember if I have more than one type of columns. Maybe actor. And let me try actor, see what happens. Does it work? Yeah, it kind of works, but it's too complex. Okay, so never mind. If you have two, then it's kind of, it kind of put things in the, I guess, double. Usually I just do one column when I do value counts because actually seeing the frequency of your entry, sometimes it can be useful. For example, like when I do some grading, I want to see how many students got A. Like that, right? Actors? When you see, I'm not sure I understand what you want. Sorry.
You just click play at just 2 minutes ago. And
2 minutes.
You see
Actors. I have actors somewhere here. Okay. I might change it something here. I don't know. Did I change like actors from here? I'm not sure. I'm not sure what I did.
I think you changed it on the last line.
The last line?
So there was displaying the genre.
Actors like this? Okay. Okay. So this one is getting the kind of like the unique combination of genre and actors. So maybe you can see that there are these two, like this combination appear 2 times in my data. I think this is transformer. So transformer 1 and 2, right? It's the same actor, right? It's the unique combination between these two. That's what it is. Make sense? Yeah. Mm-hmm. As you can see that this list is pretty old. I haven't updated my data for a long time. It's a good movie. Actually, I like Transformer 1, it's much better. My kids really like it. Like, he keeps jumping up and down whenever like the new guy transforms. But when he sees Transformer, he doesn't like it. It's because it's too much noise. Like the live action ones, like my kid doesn't like it.
Because he's too young, right?
Yeah, it's like, it's too much noise and too much like clutter, right? But then when he watched Transformer 1, he's like keeping jump up and down. Like he actually understands it, so. Okay. Let me continue a bit before we go to the break because it's been a while. Okay. Let me just go into okay. So another thing that I can show you is that if you want to get like maybe like the top most frequent things, entry, you can kind of chain things. For example, if I look at the genre, right, it gives me a lot of things in here. But certainly, like what is coming out in here can be chained. For example, I can do head and then 20, then I get the 20, like a 20 most frequent genre in my data, something like that. So you're gonna see this quite a bit when you're chaining all the operations. Then you can get a lot of things done in one line. So that's what I wanna show you. Okay, so let me give you a bit of the deep dive into how you actually select the data, because there are many ways you select the data. So I guess what I've been telling you is that the most, I guess, the way that you should do first would be to do log, right? So you do movie, right? df.log, and inside you do two things. Remember, as I told you, this one, right? So that would be the recommended way. But as you start using this a bit more, then you're going to find that this one is quite tedious, because there's a lot of shorter ways to do. For example, if I only want the row, I can just simply eliminate it like that. This one just give me all the rows. Sorry, if I eliminate this, right, I can just do row. This one give me all the rows, right? If I want to do just couple rows, I can do list in here, and I can start doing something like this, right? I want to select Guardian of the Galaxy until, maybe, actually, sorry, I don't have. Let me just do this, because now you can see the difference. Right? So the original way would be something like this. Okay, like that. So right. And if you want to select a couple rows, so that would be everything, right? But if you want to select just maybe 3 rows, then you can do Guardian of the Galaxy, right? And then this is going to take some time. Prometheus, Studio Split, yeah. And that one, okay? So this one gives you 3 rows, right? So notice that it's basically changing the colon, which is everything, replaced by the list, okay? But the same thing can be done with just this. I don't have, if I want to select all the columns, I don't even need the colon behind it. So this is all I need, and it just do the same thing. Do you see what happened? Like, as you start using it, you're gonna start to get the shorter hand version of the selection. But as I tell you, like, start with the location for log first, and we can kind of start to put things a bit like it, right? So, but another way that you can do is actually, like, this one is too tedious. I have to write 3 things. I can reduce it even further. I'm gonna take the enclosing square brackets out, and I'm gonna change this one with the colon. And it's actually achieving the same thing. See that? So, I mean, as you develop more, I guess, accustomed to this, then this is probably going to be something that you end up with, something like that. So, without the enclosing brackets, you can do start to end. Okay? So, that is a row selection for you. Maybe I should update this in my example. This one is better explained. Same thing with the columns, okay? For the columns, let me show you again. If I want to select maybe a couple columns, right? If I want all the rows and couple columns, I would start with log first. So I would do colon, and then in here I would choose maybe rank, right? I would do rank, genre, and description. So I will just do that, show you that. Okay, rank, genre, and description. So I don't need this one, right? And then that one. Okay. So with this, wait, doesn't work. Sorry. I don't need this one. It's too long, like that. See? So right now, if I were to do this, I select all the rows, right? And then 3 columns, okay? So that's the standard way to do. But you can make it shorter. If you want all the rows, then you don't even need to specify it. You can do something like this. You can remove the row, right? But this one is actually similar to the one above, right? Because this one will give you, it's almost like the row selection. So what you want to do is remove lock away with the dot, like that. Actually, this one actually goes into the brackets. So that is the same syntax. It do the same thing, but shorter. So again, there's a difference between using lock and without using anything. So that is column selection. And if this is too long for you, another way you can do is doing that. This and rank, you rank until description. Okay. So that would be the shortest way, which is wrong because rank is, wait, what did I do? Doesn't work. Key error. What? Oh, okay. I was wrong. It doesn't allow. So I think this one, I think, okay, so forget what I just said. This is the same. Okay. So usually you might end up with something like this, but I think that's the better way to do. Let me just make sure that's, like I remember it's something like this, but why doesn't it work? Description? It's weird. Okay, I can do, okay, so this one doesn't work. Okay, so forget what I just said. Okay, sometimes I forget things. Okay, so that would be, I guess, the most thing you can do. I thought you can do like colon things in here. Let me just try. I am a little bit stubborn. I want to see how it works. Okay, let me just check it out. But this one should not work. This one doesn't work. Yeah, does not work. So I guess I have to stick with lock then. Okay, that's fine. Okay, that's fine. Okay. I guess the moral of the story is that use lock first, and once you get more comfortable, you're gonna develop your, I guess, your style to be something shorter. I guess that's my, I guess that's my 2 cents. Okay. Something on top, give me error. Okay, so lastly, before we go to take a break, is maybe you might want some things that, like sometimes it doesn't make sense to use the indices. Like it makes sense to use the actual like ordinal numbers. So Panda also got you covered in this case. So I can do something like this, movie df dot I log. So there is a difference between log. Log means that you're gonna find things by the indices. But I log meaning finding things by just the index. For example, if I want the first row to the 10th row, right? Actually, this, 10th row. And then I want the first column to the 3rd column. I can get that too. So see that? So the way that it works is similar to what you have been learning so far. Like the first number is the index. So 0 is the first item. The 10th, it's actually 10th mean the 11th item, but if it's behind the colon, it's the item beforehand. So it's the one before. That's the one before thing, like that confusing part about selecting things in string. The same thing come back to haunt you in this case, okay? So again, if I do 0, that means the first column. 3 is the 4th column, but before, the one before, if it's after the column, okay? So maybe sometimes it makes sense to do something like this, then you certainly can. So it is called ilog, okay? Okay, so maybe we'll take a couple minute breaks and we'll come back for the last sessions.